हाँ आ गया।
आ गया ना।
हाँ सर।
अब इस पे लेकिन वो कहाँ आ रहा है?
ये लाइव हो गया।
हाँ वो तो हो गया। इस पे यूट्यूब वो आना चाहिए ना, मीट वाला, ये वाला आना चाहिए ना। नहीं
स्टार्ट ब्रॉडकास्टिंग है।
नहीं इसमें है, फिर इस पे आना चाहिए ना। ये हमारा, ये तो सही चल रहा है।
हाँ सर डला हुआ है।
यही है ना।
हाँ सर।
हाँ यही है, आ रहा है ना।
हाँ सर ये है ना। अभी उन्होंने वो नहीं किया ना सर, एक्सेप्ट नहीं
हाँ आ
किया।
रहा है।
हाँ।
और यूट्यूब पर अब देखना पड़ेगा मुझे लाइव ये दिखा रहा है कि नहीं। आप उधर ओपन कर दो। आ रहा है।
आ रहा है ना। हाँ सर गूगल मीट पे फिर।
ठीक है, रिकॉर्डिंग शुरू करना है, शुरू कर देता हूँ।
ये 10 मिनट है सर।
10 मिनट।
एक बार लॉगिन तो करते हैं सर।
लॉग इन कर दो, एक में इकोनॉमिक्स, एक में फिजिक्स
कर दिया हूँ सर, और इकोनॉमिक्स 10th में कर दिया हूँ।
साइंस कंप्यूटर लैब में कर दो। जयंतो जी, आपका लिंक लाइव है, जुड़ जाइए। ठीक है। हाँ संदीप जी, एक बार ये कंप्यूटर लैब में आके बैठिए। साइंस का ऑनलाइन क्लास चलेगा ना अभी, उसमें थोड़ा देख लेना।
नमस्कार सर।
नमस्कार नमस्कार।
Good morning, you all.
फिजिक्स है
हेलो। हाँ, स्टार्ट कर दीजिए, आपका टाइम हो गया, आप तो स्टार्ट कीजिए। रख दीजिए, मैं कर दूँगा, रख दो।
Good morning, my dear students. So today is the first class for the low achievers of Shillong region students. Mm, at first, I am very much thankful to RO Shillong for choosing me to take this 2 day class for me today and tomorrow. And I will cover the chapter 1, chapter 2 and chapter 3.
क्लास स्टार्ट कीजिए सर, जल्दी करके।
Um,
टाइम रोज 5 मिनट निकल जाता है।
in physics, the first 3 chapters, it is a scoring one, and the first chapter is electric field, electric charge and field. So second chapter is electric potential and capacitance, and third chapter is current electricity. Uh, Students, since time is very less, so we are directly. I think my screen is shared to you all, and we can just recapitulate our knowledges. The very first topic is the electric charge. As we know that it is the uh, intrinsic property and of particles which gives rise to the electric force between various objects. Actually,
सर गुड मॉर्निंग।
the electric charge is the
ये सर, ये
excess or
मेरे यूट्यूब
deficit
पर
of
लाइव तो हो गया,
electrons. In
लेकिन
a
जो
very
स्क्रीन है
simple
ना,
language, it
वो
is the
पूरा नहीं
excess
दिखाई
or
दे रहा
deficit
है।
of
उसको छोटा बड़ा
electrons
करने का,
which gives rise this intrinsic property, and that intrinsic property is the
स्क्रीन जो है ना,
electrical
गूगल
force
मीट पे तो पूरा दिख
between
रहा
the
है,
two bodies.
लेकिन यूट्यूब
And
पे जो है पूरा नहीं
actually
दिखाई दे
the
रहा है।
electron which are residing at the outermost orbit, they are loosely bound to the atoms. So because of the friction, these
हाँ,
electrons get affected means they get shift from one body to the other, and
स्केल
because
टू
of
विंडो
that
लिख
this
रहा है,
excess and
60%
deficit
आ
of
रहा है, लेकिन
electrons
उसको कम
occurs,
ज़्यादा
and
करना नहीं
that
आ
which
रहा
gives us the property of electric charge. So Millikan was the
है। हाँ सर, कम
first
ज़्यादा करने का
to
नहीं आ
find
रहा।
out the value of elementary charge, that is the excess or deficit of one electron that
टाइम
will
है क्या
give how much amount of charge,
सर?
and the charge is measured in coulomb
काफ़ी कट रहा
in
है
SI
स्क्रीन ना।
system and stat coulomb in CGS system. And one electron, deficit of one electron or excess
हाँ
of
हाँ,
one electron actually carries the charge equivalent to 1.6 into 10 to the power minus 19 coulomb. That I think most of you know it.
कोने से ऊपर
And
नीचे क्लिक हो रहा है, देखो।
since proton is also carrying the charges, so that proton carries positive same amount of charge. One proton carries same amount of charge, but it is positive in nature, and it is 1.6 into 10 to the power minus 19 coulomb. So the fundamental charges, as we say that it is of two types, positive as well as negative. And we all know that similar charges repel, and opposite charges, or unlike, I can say unlike charge, they attract each other. And we have some basic properties of electric charges, like electric charges obeys additive rule. And additive rule means charges can be added, just like masses can be added. When two or more masses are combined together, the total mass is the sum of all the masses. Like that, when two or more charges are combined, the total charge is the sum of all those charges. Then electric charge obeys conservative principle, that total charge of a system remains always constant. There is we cannot what just like the conservation of energy principle, energy can neither be created nor destroyed. Like that, electric charge obeys the same rule, that we can neither create nor destroy the electric charge, but the total charge can be conserved in a system. And the most important thing that is required in our class is the quantization of charge. You all can have this as the give a star mark, because from this topic they are asking a question, 1 mark question you may be getting. What do you mean by quantization of electric charge? That means electric charge in case of a microscopic object. Microscopic means when we are dealing with a very small amount of charges. In that case, the total charge of the body is the integral multiple of the uh, elementary charge. As I said, that elementary charge is the charge carried by a single electron or a proton. So, and that we all know what is that value. That is 1.6 into 10 to the power minus 19 coulomb. So, how many electrons get transferred? That number, and multiplied with the charge of one single electron, that is called the uh, elementary charge. So if your number of electrons get transferred is n, and if he is the charge of the electron, that total charge that that is transferred, that q can be written as n into e. That is why it is called that integral multiple of the basic charge. E is the elementary charge or basic charge, and it is the charge carried by a electron or a proton. So I have a question for you. Calculate the total
ये
negative
स्क्रीन जो है
charge
ना,
in 2
देखो
moles
इसमें छोटा
of
बड़ा नहीं
water.
दिख रहा है,
So how many electrons
समझ रहे हो?
we are having in these 2 moles, that we have to calculate, and then
इसको
we have to
कंपेयर कर
put it
सकते हैं ना,
in this formula. So we
यहाँ पे
need the
भी
number n, we need number of electrons.
ऐसे कर सकते
So
हैं, लेकिन छोटा बड़ा
we
नहीं
have 2
दिख
moles
रहा
of water. So 2
है। हाँ
moles of water means 1 moles of water carries 6.023 into 10 to the power 23 number of molecules. So multiplied by 2, we are getting number of molecules. Now in water you can see H2O. So 2 hydrogen and 1 oxygen. So 1 hydrogen carries 1 electron. So 2 hydrogen means 2 electron, plus oxygen carries 8 electron in outermost orbit. So 2 plus 8, that is 10 electrons in one water molecule. So as we know that 2 moles of water contains this number of molecules, so it will be multiplied with 10. So we get the total number of electrons. So the quantization of charge says that Q
अब
is
देखो
equal
आपकी
to
यूट्यूब लाइव
N
चल
into
रही
E. So
है और
Q becomes
मैं
N means 2, 2 into this N means 2 into 6.023 into 10 to the power 23 into 10. Then charge of electron is 1.6 into 10 to the power minus 19 coulomb.
मेरा
So
भी
Q
यूट्यूब में चल
becomes
रहा
this much answer, this much coulomb of charge is carried by 2 moles of water. Then different methods of charging. So charging is actually frictional electricity says that it is charging by friction. So if we rub two bodies, charge can be transferred from one body to another body. So you can have this one. The simple example is that when a glass rod, in my class, I generally used to say that when a glass rod is rubbed with silk cloth, so electrons from glass rod, they are loosely bound in compared to the silk. So that's why the electrons from glass rod get transferred to the silk cloth, making there is a deficit of electron occurs in glass rod, and there occurs excess of electrons in the silk cloth. So the excess of electron we are denoting by negative charges, and deficit of electron is denoted by
There is
plus
one
sign.
full screen
So this process, there are some other examples also. So the same in this one, the glass rod when rubbed with silk cloth, it is glass becomes positively charged and the silk becomes negatively charged. So when these two are combined again, they become neutral again, and that is the best example that electric charge obeys conservation principle. The conservation, as I said, that total charge of a system remains always constant. This is the best example. You first rub the glass with silk, and after rubbing, the glass becomes positively charged and silk becomes negative. So when these two are again combined, we will see that they lose their charges. So this means that the charges get again transferred to their original positions, making them neutral again. So this is the, I think this is the best example of conservation of electric charge. Then some other examples are also there that when a plastic rod is rubbed with ebonite rod is rubbed against far, then also we get that the rod becomes negatively charged and far becomes positively charged. A lot of examples are there. Next is the one more important topic, that is the electrostatic induction, means charging by induction. Induction means without touching. Without touching the two objects, we can also charge it. And it is called the induction process. That means the process of charging an uncharged body with the help of a charged body without touching them with other. So simple example that say there is a body A which is positively charged. When it is brought near an uncharged body B, so because of these positive charges, the negative charged electrons will be attracted to these positive charges. So negative charges will be coming to this side and positive charges will be accumulated to the other side. So when the second body, the body B, is grounded, what we see that the negative, these positive charges are in book or in copy, we generally say that the positive charges are flown to the ground, but it is not happening like that. The negative charges from the ground, they are coming and they are neutralizing these positive charges. So all the positive charges are gone to the earth. So the body is now carrying negative charges, but these negative charges are unable to move to the ground because they are attracted by the body A. That's why they are unable to move. So now when the grounding is removed, when this earthing connection is removed, we see these negative charges are appearing on the body B. So see, without touching the two bodies, we are making this uncharged body B as a negatively charged body. So this process is called induction. Next is charging by conduction. It is also there. It is simple one that when a charged body is connected to the other body, it is the process of, it is written there, it is the process of charging, in which one charged body is touched with another charged or uncharged body, the total charge is shared among them. So this charge body, when connected to this one, the total charge is carried by all these two together. So that is called charging by conduction.
यहाँ पे सेटिंग में क्या है?
Then one more thing, permittivity of a medium. It is it is the property of the medium which determines the electrical force between the two charges situated in that medium. So we'll discuss it later on. Before that, let me discuss the Coulomb's law, which is one one of the important topic. From here, generally numericals are asking, and Coulomb's law is a basic law
डिपेंड्स
that gives us the electrical force between two
हाँ,
point charges. You all know that point charges means two charges are said to be point charge if if they are at a far distance from they are at a far distance, means the distance between them is very much bigger in magnitude than their sizes, then the two object in that cases are said to be a point object. So there are 2 point charges, say Q1 and Q2. See here, they are denoted by dot mark and their distances are very much bigger in size. So in such cases, the two charges are said to be point charges because the distance is large enough. So Coulomb's law is applicable. One limitation may be asked to you. What are write one limitations for Coulomb's law? So that is the thing, that Coulomb's law is applicable for point charges only. So yeah, the force says the Coulomb's law says that the if F be the force between two charges Q1, point charges Q1 and Q2, then and they are separated by distance r, say in vacuum, then the electrical force is force of attraction or repulsion, whatever may be, depending on the two charges, the force may be attractive or repulsive. So that force, if I take the magnitude, that force is directly proportional to the product of the two charges Q1 and Q2, and it is inversely proportional to the square of the distance. So when these two are combined, force becomes proportional to Q1 Q2 by r square. So F is a constant term k comes. This k is called constant of proportionality, or sometimes it is called Coulomb's constant. So this k, it depends on the system of units chosen. So our system can be CGS system as well as SI system. So we are generally doing the we are following SI system, not CGS system. So in SI system, this k value is 1 by 4 pi epsilon naught. This epsilon is actually the permittivity of the medium. So if it is vacuum, so here it should be air or vacuum. For air or vacuum, it should be written as 1 by 4 pi epsilon naught. See, epsilon naught is giving us it is the permittivity of free space or air. It is called absolute permittivity of the medium. Now, most of the people thinks that what this signifies, permittivity, means it one kind of thing I can say that it is suppose if we want to visit from one country to the other country, we need the permission. So in the medium, the two charges are reacting. Reacting means that is they are either attracted or repelled by the force. So that to attract or repel by the force, they need permission from that medium. And this epsilon, it is indicating that one. So in a very simple language, we can say that permittivity of a medium gives the easiness or difficulty of a medium, which allows the electric field to pass through. So, so in other medium, if the medium is other than air or vacuum, so we can write it as F is equal to 1 by 4 pi epsilon. So this epsilon is called only, it is simply called the permittivity of the medium, not absolute. If epsilon naught is there, it is absolute permittivity. In that case, we we should think that the medium is either air or vacuum. So the relation between this epsilon and epsilon naught is this one. The means epsilon. This epsilon r is there. See, you can see. So this epsilon can be written as the product of epsilon naught and epsilon r. This epsilon r is
हेलो
called
सर.
relative permittivity.
सर जरा देखना
It is
बाहर
the
भैया आए
relative
थे, वो परचेस
permittivity
करना
of the
था.
medium. So this the
यूट्यूब पर
relation sometimes it
यूट्यूब
is
पर देखना
required.
जरा.
Epsilon r is epsilon by epsilon naught.
अच्छा लिंक
So
लिंक
you can note it down. That is the relation. We need this
अच्छा
one
यूट्यूब
only.
लिंक
This
भेज
is
दिया
the
सर वो.
important one
अच्छा
for ER or vacuum. When
आपके
numerical
पास
is
कैसे
coming,
लिंक.
they are asking this formula. They need this formula in CBSC, where we can use only this formula.
हाँ नहीं मेरे
Numerical value of this for ER or vacuum, huh? It is if I
मैं तो
put
देख
all
पा
these
रहा हूँ
values and epsilon naught value for ER
दूसरे
or
डिवाइस
vacuum,
पे.
it is
दूसरे डिवाइस पे.
8.85. 43 is also there, but we will remember it up to second decimal place. 8.85 into 10 to the power minus 12 coulomb square per newton per meter square. So if we put
ये
all
ऐसे
these
चल रहा है
values
ठीक
here,
है.
this constant term comes around 8.9
नहीं नहीं
something.
चैनल पहले
So
दूसरे
better we
पे.
can use 9 into 10 to the power 9
हाँ
Newton meter square per coulomb square. So this value you should know this
चलता है
the
मेरे यहाँ
in
देखो.
using Coulomb's
ये
law.
दूसरे
When
ये
numerical
ये
ask,
अकाउंट से
this
लॉगिन किया है मैंने
constant
परचेस.
term directly can be written as 9 into 10 to the power 9. So the numerical will be easier one. Otherwise, if you
अच्छा
don't
देखो
know
एक
this
मिनट.
value, it will be difficult for you to solve the numericals. Then for you people, the one more important
नेटवर्क इशू
topic
दिखा रहा है क्या.
is vector form of Coulomb's law.
नेटवर्क इशू के
So
कारण हो गया.
till now, I am not using any
एक बार
vector
मैं कट
symbol.
करता हूँ फिर
So
देखना.
for vector symbol, see this thing, you need to know that this suppose this is F21 is written, no? So 21 indicates that it is the force on charge Q2 by charge Q1. This marks should be noted down that F21 means force acting on charge Q2 by charge Q1. So in that case, this magnitude part is this one, magnitude part is this one. This magnitude part is no problem, but we need a direction. So that direction is given by you, I think you all know, it is given by the unit vector. It is given by the unit vector. So R12 cap, this cap indicates the unit vector, and this direction is also it is showing that the direction is from, since it is the force acting on charge Q2 by Q1. So this direction, see here, the symbol is showing that this direction is R12. This direction is vector leading from charge Q1 to charge Q2. So Q1 से Q2 तक जो डायरेक्शन है वही डायरेक्शन शो कर रहा है. तो वो डायरेक्शन शो कर रहा है बाय यूजिंग दिस यूनिट वेक्टर, बाय दिस यूनिट वेक्टर. So generally we are writing the Coulomb's law in vector form in like this one, but please note down that this direction should be mentioned in the diagram. डायग्राम में वो देना है कि आप कौन सा डायरेक्शन लिए हो. So if you reverse it, say you can also show it by R21. R21 अगर R21 दे दिया तो इधर डायरेक्शन दिखाना है जे it is also R21. So better you should show these things in diagram. तो if अगर डायग्राम में दे दिए तो आप लोग there will be no issue that you will not be getting any marks. So the examiner will find your answer in the diagram also. Then similarly the force, you can also write the force acting on charge q1 by q2, then that can also be written, but only one formula is sufficient to get the marks. They are not asking the two things. The f If you are writing f21, it is sufficient, or you can write f12 also, because only they will be giving you only 1 mark. Then, as I said, na Coulomb limitations of Coulomb's law, nowadays they are giving one tail question, साथ में एक क्वेश्चन जोड़ देता है, तो limitations of Coulomb's law is there. So Coulomb's law cannot be applied if the charges are in motion. So as I said, na Coulomb's law is applicable in point charges, that can also be given there. Then the second point is there, Coulomb's law is only applicable for point charges. That is, the sizes of the charges must be small as compared to the distance between them. Then separation between the charges must be greater than 10 to the power minus 15 meter. Means this is called 1 Fermi, this distance, because if it is less than this distance, or if it comes to this distance, then again nuclear force comes into play. So better you should recall these two. Coulomb's law limitation, first two is sufficient for you people, that it cannot be applied if the charges are in motion. It is applicable in charges at rest, and charges must be the point charges only. So if you numerical are there, so I will share this PPT in the group. You can have this PPT.
Sir, excuse me, Jento sir. Sir, sir, can you hear me?
Next is that forces between multiple charges, so which is called superposition principle. If there are more than two charges, the total charge, total force acting on a single charge due to the all the charges is the sum of the individual forces acting on that charge due to those individual charges. Just a minute, I want to share you. Actually, the main topic is the कौन सा? हाँ, ओ अच्छा, ठीक है सर। जिस ये जो चीज़ है So next is the electric field, one of the most important topic from chapter 1, electric field. It is the force experienced by a unit positive test charge placed at a point in an electric field. Actually, electric field is the region around the charge where its effect can be found. So that region is called the electric field, and we can find that electric field intensity at a point. So to know the effect, we have to bring another charge. So that another charge which we are bringing, and that charge is called the test charge. And we assume that the test charge should be positive test charge, but it is not always correct. The test charge can be negative also, but for theory part, we are taking the test charge to be positive test charge. So when the test charge is brought to the electric field, it is either attracted or repelled because of the electrical force of the existing charge. So that test charge should be small enough. It is written there that test charge should be small enough so that अगर test charge बड़ा है तो उसका भी एक field आ जाएगा. So, but we are trying to find the field of other charge. So that test charge should be very, very small. And because of that, in the definition, we are using a limit. That test charge, if test charge is Q0, that test charge should be negligible, means it should be tending to 0. So it should be very, very small. So अगर एक charge है Q और टेस्ट चार्ज Q0 लाया जा रहा है, दोनों के बीच में इलेक्ट्रिकल फोर्स F है। तो मुझे तो यूनिट चार्ज चाहिए, तो यूनिट टेस्ट चार्ज में कितना फोर्स होगा? Q टेस्ट चार्ज इज एक्सपीरियंसिंग ए फोर्स F, तो यूनिट टेस्ट चार्ज क्या हो जाएगा? F/Q0। सो दैट क्वांटिटी इज कॉल्ड द इलेक्ट्रिक फील्ड इंटेंसिटी। तो generally we learned that this quantity is called electric field intensity or electric field strength. Nowadays it is given the shortcut, we can use electric field. It is understood that electric field is nothing but the electric field intensity. ये समझना है कि इलेक्ट्रिक फील्ड इंटेंसिटी और इलेक्ट्रिक फील्ड स्ट्रेंथ is can also be termed as electric field. तो ये जनरली कंफ्यूजन टर्म है कि इलेक्ट्रिक फील्ड जब हम लोग टीचिंग करते हैं, बिगिनिंग में बता देते हैं कि द फील्ड around a existing charge where its effect can be understood or find out, that region is called electric field. लेकिन मैथमेटिकली जो फॉर्मूला आ रहा है उसमें एक्चुअली हम लोग उस फील्ड का स्ट्रेंथ और उस फील्ड का इंटेंसिटी निकाल रहे हैं। तो इंटेंसिटी निकालने के लिए टेस्ट चार्ज लाना है, तो टेस्ट चार्ज सपोज Q0 लाया जा रहा है, तो टेस्ट चार्ज Q0 जब लाया जा रहा है उसमें F अमाउंट फोर्स एक्ट हो रहा है, F अमाउंट ऑफ फोर्स एक्ट हो रहा है। तो मुझे तो यूनिट टेस्ट चार्ज चाहिए, तो यूनिट टेस्ट चार्ज में कितना फोर्स एक्ट होगा? F/Q0। सो लिमिट Q0 टेंडिंग टू 0 इफ इट इज गिवन, इट इज टेलिंग अस दैट ये जो Q0 टेस्ट चार्ज है इसका मैग्नीट्यूड बहुत ही कम होना है, नहीं तो इसका भी तो एक फील्ड आ जाएगा। इसीलिए तो मेक इट nullify, we are taking this Q0 to be tending to 0 but not 0, nearer to 0. So this is the mathematical formula for electric field or electric field intensity. So since electric field intensity is the force experienced by a unit test charge, so unit test charge, so it is a vector quantity. We can say that it force experienced by a unit positive test charge. So that's why since force is the vector quantity, so electric field is also a vector quantity. Now see, one point is here: if a positive charge is kept in an electric field, then the force on it will be in the same direction as that of the field. फोर्स जिस तरफ है फील्ड भी उस तरफ ही होगा। बट इफ इट इज ए नेगेटिव चार्ज इज केप्ट इन एन इलेक्ट्रिक फील्ड, देन द फोर्स ऑन इट विल बी इन द ऑपोजिट डायरेक्शन एज दैट ऑफ द फील्ड। द मोशन डिपेंड्स ऑन द स्ट्रेंथ ऑफ द फील्ड, स्ट्रेंथ मीन्स फील्ड इंटेंसिटी, charge of the particle and also the initial velocity, but it is not required for you people. Then units of electric field. इलेक्ट्रिक फील्ड का एज आई सेड दैट इट इज द फोर्स पर यूनिट टेस्ट चार्ज, तो फोर्स यूनिट ऑफ फोर्स इज न्यूटन एंड यूनिट ऑफ चार्ज इज कूलम। सो न्यूटन पर कूलम इन एसआई यूनिट। इन ESU system means SI CGS system, it is dyne per stat coulomb. You can recall this, but it is not required for our exam purpose. Then dimension is also there. Dimension, फोर्स का डायमेंशन है m1 l1 t-2, चार्ज है दिस A is for एम्पियर, तो current into time is called charge. So the current means A, it is denoted by, in dimensional analysis it is denoted by A, and time is capital T. So when these two are simplified, we are getting that it is m1 l1 t1 ऊपर जाने से माइनस, तो t-3 A-1. तो दिस इज द डायमेंशन फॉर इलेक्ट्रिक फील्ड और इलेक्ट्रिक फील्ड इंटेंसिटी. Next, physical significance. An electric field plays an intermediary role in the force between two charges. The electric force on a charge is due to any source may be treated as two-stage: charge, electric field. Then चार्ज होने से इलेक्ट्रिक फील्ड रहेगा, इलेक्ट्रिक फील्ड है तो उसमें चार्ज है. इसका मतलब the source charge produces a definite field around it. The field at any point determines the charge force on a charge placed at that point. But you can think, as I said, na, the electric field, it is the whenever physical significance comes, only you just recall the definition that electric field is the force experienced by a unit positive test charge placed at that point. That means there should be a charge, and that charge should have an electric field, and on that electric field is another charge is there, it is experiencing a force. The definition says everything about the significance. That's why the two arrows are given here. Two arrows are given means there should be a source charge, and that source charge should have a field, and on that field if another charge comes, then it is countered by an electrical force. So that what says about the physical significance. But this is actually truly for the electric field, means statical electricity when the charges are at rest. But in magnetism it is a complex one. In magnetism what we say that the charges when they oscillate, means with a special acceleration, oscillation is a kind of special acceleration. When a charge oscillates between two fixed points, it creates an electrical field, and that electric field when travels through the space, uh, and when it comes across a charge, it exerts a force. The same thing means in case of magnetism, the charges, it is oscillating with an acceleration, and because of that acceleration an electric field is created. And that electric in chapter 8 you will be taught in next classes how electromagnetic waves are produced. There also you will get this topic. When the charge oscillates with an acceleration, then they produce an electric field, and that electric field when travels through the space, and if it comes across a charge, and it exerts a force. So in that way also in magnetism we are defining we are getting the significance of electric field. But here only on the for exam purpose these notes are given. Next one, numerical is there, but as time is short, so let me first discuss the theory part. Then electric field due to a point charge, it is required for exam purpose. This is a very short note that as I said that the force experienced by a unit positive test charge is called electric field. So say you are taking a source charge Q, and at a distance r a test charge Q0 is kept, and it is bringing from infinity. So in that case what will be the force between the two charges? One is Q, another is Q0. So F is 1 by 4 pi epsilon naught Coulomb's force. It is Q0 by r square. So in our last slides we found that the product of since force is electric field is the force per unit test charge. So test charge आ जाने से इस तरफ आ जाने से it gives us electric field. So that means Q in electric force, it is the product of electric field and test charge. So this instead of this force I am writing it is E into Q0. So this Q0 gone. So see electric field, it is becoming 1 by 4 pi epsilon naught Q by r square. So in vector form also give a vector sign here, and as I said na, in for vector form we need a unit vector. So the unit vector direction is same as this vector. So you put in for you people. Field in vector form can be written as, if it is not asked don't write, otherwise this answer is sufficient. electric field due to a point charge is 1 by 4 pi epsilon naught q by r square. Or if you wish, you can also write in vector form. So be careful while writing the answer in your answer book. अगर वेक्टर साइन दे दिए तो राइट साइड में भी वेक्टर्स देना होगा. Next, principle of superposition of electric field, just like electric force, they obey सुपरपोजिशन प्रिंसिपल. तो इलेक्ट्रिक फील्ड भी सुपरपोजिशन प्रिंसिपल जैसे अगर इफ देयर आर मल्टीपल चार्जेस आर देयर, तो superposition principle comes into play, that electric field at any point due to a group of charges is equal to the vector sum of the electric fields produced by each charge individually at that point. Now, before proceeding to one more topic, see, we need a term called linear charge density. The name itself says that linear charge density means charge per unit length. Charge per unit length is called linear charge density, which is denoted by lambda. Lambda is q by L. So if there is a uniform charge distribution, you can also write it as dq by dl. But try to recall it by charge per unit length is called linear charge density. Then surface charge density is also there. Surface charge, the name itself says that अगर एक सरफेस है उसमें कुछ चार्ज है तो उस चार्ज को उसका सरफेस एरिया से डिवाइड कर दोगे तो इट बिकम सरफेस चार्ज डेंसिटी और सिंपली चार्ज डेंसिटी. So total charge carried by that surface divided by the area. So charge per unit area will give us surface charge density. Then one more term called volume charge density. Charge per unit volume. The name says that charge per unit volume. So charge per unit volume is called volume charge density. Excuse me. अच्छा अच्छा ठीक ठीक हाँ सर सर हाँ सर.
जयंतो सर जयंतो सर नलवारी स्कूल ने हैंड रेज किया है, कोई उनका क्वेरी होगा.
सर हेलो सर, कहाँ गए आप?
जैन तो सर स्क्रीन में है। जयंतो जी, जयंतो सर, आप सुन पा रहे हैं मुझे?
हाँ सर, अभी आया है सर, आ रहे हैं सर।
हाँ हाँ।
जस्ट अ मिनट, सॉरी फॉर द डिस्टरबेंस। एक मिनट मुझे टाइम दीजिए।
ओके 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 ओके।
Sorry for the disturbance. Uh, am I audible now? So electric dipole is one of the one more topic that two equal and opposite charges when separated by a small distance, finite distance, it is making us an electric dipole. So that for that dipole we need uh, two charges. One is say plus q, another is minus q, and they are separated by a distance 2a. 2a, why it is given 2a? That because the midpoint of the two charges is at a distance a from this charge and at a distance a from this charge. That's why for doing numerical purpose or calculation purpose, if we take it as a 2a, the distance between them, it will be better for us. So this 2a is called the dipole length, and the product of the magnitude of the charge, and this dipole length, it is called the dipole moment of that dipole. So dipole moment is taken as a vector quantity, and in that vector quantity it is denoted by p. Here actually it is p is capital, but better to use p as a small letter. So that vector sign indicates that it should have a direction, and that direction we assume to be taken from minus q to plus q charge. माइनस जो निगेटिव चार्ज से पॉजिटिव चार्ज के डायरेक्शन में वो डायरेक्शन लेना है डाइपोल मोमेंट का. सो दिस प्रोडक्ट ऑफ दिस magnitude of the either charge and the dipole length, it is called dipole moment. Next is the electric field on the axial line. So before that one, before starting this one, let me ask you one question. In CBSE, they are asking one in that a quantity, which physical quantity has unit Newton per coulomb. Suppose this question is there, which physical quantity as unit Newton per coulomb. So Newton per coulomb किस physical quantity का unit होता है? So this, and is it scalar or vector? Is it scalar or vector? So this type of question they are generally asking. So I think you all you will be giving, you can give the answer. Let me see.
जयंतो सर आपका बोर्ड विजिबल नहीं है.
Which physical quantity has unit Newton per coulomb? So just now I taught it is, thank you, I got the answer. It is electric field, and it is a
जयंतो सर आपका स्क्रीन
vector
विजिबल
or
नहीं
scalar
है.
quantity. It is a vector quantity. So one more here, this from dipole moment part also they are giving the question that which physical quantity has unit this charge into dipole length. So coulomb into meter. Which physical quantity has unit coulomb into meter?
जयंतो सर सुन पा रहे हैं क्या?
So coulomb is charge and meter is dipole length. So product of these two gives dipole moment. So the dipole moment has got unit coulomb into meter. Thank you. So again let me come to our topic, that electric field on the axial point. So you will all, if I go on discussing all these points step by step, it will take a long time. So you have to recall that electric field at an axial point of a dipole is this formula you need to know, that it is the electric field on the axial line is 1 by 4 pi epsilon naught 2 pr by r square minus a square whole square, where r is the distance, and this r, always remember this r is taken from the center of the center of the dipole. So dipole का जो center है वहां से लिया जाता है ये r distance. So then similarly on the equatorial line, so let me tell you that what is the axial line. Axial line matlab the line joining the two charges. The line joining the two charges is the electric the axial line. And uh, equatorial line means the line which is passing perpendicularly through the axial line, which is passing perpendicularly through the axial line. It will give হ্যাঁ আচ্ছা 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 এক মিনিট দেখছি তো কি হচ্ছে
देखो तो सही नहीं टेकन कर पा रहे। सही नहीं टेकन कर पा रहे ना।
and then the equatorial line means the line, imaginary line which is passing perpendicularly
सही आ रहा है कि देखो
perpendicularly through the axial line through the center of the सर कोई सवाल पूछ रहा है लेकिन सेंटर काम नहीं कर रहे मैंने सुनाई नहीं दे रहा सपोज sorry for the disturbance. Shayad somebody is asking me question, but I am unable to get that voice. Just a minute. Sound. Oh. Okay. So this on the axial equatorial point of a dipole, the electric field on the equatorial line is same as the previous one, but that 2 is not required here. पहले वाले में था 2, पहले वाले में था 2, देखो इधर 2 था, लेकिन नेक्स्ट में 2 नहीं चाहिए, 2 तो दोनों के लिए कॉमन एक बनाया है कि शॉर्ट डाइपोल होने से if they for a short dipole this distance r, it is much larger than the half of the dipole length, or you can say dipole length. In that case, in the denominator part, this a square can be neglected, so that can be written as r square. In both the cases, if I put here just a minute, in the previous slide, instead here if I put it as r square, if a square is neglected, this r square whole square is there, so r to the power 4 will comes, and if r cuts, we are getting r cube. So see, same thing is written here. So in axial line we can write it as 1 by 4 pi epsilon naught 2p, ऊपर एक r था और नीचे r to the power 4 था, तो कैंसिल होके r cube. एंड इक्वेटोरियल लाइन में भी सेम, वो ए स्क्वायर निगलेक्ट हो जाने से आर स्क्वायर है, ऊपर देख सकते हो आर स्क्वायर एक है और टू दी पावर 3/2 एक है, तो 2 कैंसिल होने से आर क्यूब ऑटोमेटिक आ जा रहा है, तो आर क्यूब, तो दोनों में देखो सेम आंसर आ रहा है. दोनों ऐसे याद रखना है कि एक में 2p है और एक में सिंगल p है, तो इक्वेटोरियल लाइन में जो इलेक्ट्रिक फील्ड है उसका डबल है एक्सियल लाइन, provided the distance r is fixed. Provided the distance r is fixed. Suppose there is a suppose one question I can ask you, say if electric field on the point on the equatorial line is say 4 Newton per coulomb.
सर आपका स्क्रीन छोटा है सर, ध्यान नहीं दे रहे हैं सर.
हाँ सर,
अब भरा हो जाइए सर.
if the on the equatorial line, if the electric field is 4 Newton per Coulomb, if what will be the electric field on the axial line? If this type of question comes, provided the distance r is same, this type of question if comes, so you have need to know that the relation between them there is, if r is same, the electric field on the axial line for a dipole is twice of the electric field on the equatorial line. So our answer would be 2 into 4 Newton per Coulomb, that is 8 Newton per Coulomb, like that. Next is one thing is that torque. Torque is also one important topic. That torque means if the if an electric dipole, if an electric dipole is placed in an uniform electric field, the dipole moment suppose makes an angle theta. In that case, this diagram you can see, suppose two charges consisting the dipole, one is minus q plus q, it is placed in an electric field. So this charge will be attracted to the field by a force q into E, and the positive charge will be repelled. So it is q. So the two line of actions are different. So since the line of actions are different, they will make it rotate, and that is what is called the couple. The cause of couple or rotational motion is called torque, and that torque, it is defined as, in class 11 also we got it as, the torque or the magnitude of the torque is the product of the either force and the perpendicular distance. Say this is one force, this is another force, the perpendicular distance between them we need to know. So this perpendicular distance comes as 2a sine theta by using this trigonometry. So the torque comes, the force is QE, either force is QE, so one of the force is QE. Actually here magnitude should be written, magnitude of the either force into the perpendicular distance. So QE into 2a sine theta. So from here, Q in product of charge and the dipole length is called dipole moment. So PE sine theta. So torque comes PE sine theta, or in vector form, this is like AB sine theta. AB sine theta means A cross B. So I can write it as P cross E. So this is the formula for torque, which is one more important topic. And here the confusion is there. Generally they are asking which physical quantity has unit. This see, this dipole moment has unit, sorry, here the torque, the force and perpendicular, the force is Newton, and perpendicular distance is meter. Newton into meter. One more question they are expecting from you: which physical quantity has unit Newton in meter, and what is it, scalar or vector? So sometimes we are getting the answer like, if you are writing it as a torque, if your answer is torque, then it is a vector quantity. But some students, we get the answer as it is also the answer also comes like it is the unit of work done or energy, because Newton into meter, it is also the work done, formula for work done. So sorry, unit for work done, which is called joule. So in the, if you are writing it as work done or energy, then your answer should be the quantity is a scalar quantity. So in class 12, as you are giving the exam of class 12, so if this question comes, suppose, then your answer should, I think from my side, your answer should be torque is better, and it is a vector quantity. So next, just a minute, next part is
ये मुझे लग रहा है ये वैसे हो गया
So
होगा
next is
पोटेंशियल लाइन
electric
पे
lines of
नेटवर्क
force
में ना।
or electric field lines. That also, I think you know it, that electric field lines are the force experienced by a unit positive test charge whenever placed in an electric field. So the path followed by that unit positive test charge in an electric field gives us the electric lines of force or electric field lines. So properties we need to know that electric field lines start from positive charge and at negative charge. If there is a single charge, it may end at infinity. So it can start from infinity and it can end at infinity. So basically, in our case, we are using that electric field line start from positive charge and finishes at negative charge. So in a charge-free region, electric field lines can be taken as a continuous curve without any breaks. So there should not be any break. ऐसे break नहीं देना है.
सही है।
ऐसे break नहीं देना है. जैसे suppose this is positive
यूट्यूब
charge,
में किया था
for
क्या
it
कभी?
the electric field lines are radially
यूट्यूब में किया था क्या?
outward.
हाँ? यहाँ तो
Electric
ऐसे आ रहा
field lines are
है।
radially
बहुत
outward.
वीडियो यहाँ पे लाइव
Electric field lines are radially outward for a charge which is positive, and for a charge negative, the electric field lines are like this one, like this one. There should not be any break. ऐसे break नहीं देना है, break नहीं देना है. So that break, sudden break indicates absence of electric field, which is not possible. Then if the field lines, electric lines of force are crowded one, it gives the stronger field. And if the electric lines of force or field lines are wide apart, it shows the weaker field. Some other points are also there. Electric field lines can never intersect. If they intersect, अगर intersect है तो उस पॉइंट में, एक ही पॉइंट में दो डायरेक्शन होता है, तो two directions are not possible. Suppose see, say there is a charge, this one and this one. Suppose this is one electric field lines moves from positive to negative charge. Here at this point we know the electric field, how to get the electric field at this point. If we keep the unit positive test charge here, so from this positive test charge, this unit positive test charge will be repelled along this direction, and this positive charge will attract here. So the resultant of these two is this line using parallelogram law of vector addition. So this is the resultant of this field. So this direction indicates the tangent on this curve. So that means this shows that the tangent on the electric field lines gives us the direction of the electric field. तो अगर दो field lines cross है, कहीं पे touch है, तो at that point of intersection there should be two tangents which is not possible. यही लिखना है हमें एग्जाम में आने से कि the two electric field lines can never intersect. इसका कारण पूछने से हमें बोलना है कि if they intersect, then at the point of intersection there should be two tangents. ऐसे भी लिखने से होगा, नहीं तो there should be two directions which is not possible. ये दोनों पॉइंट याद रखना है आप लोगों को. Next, I'm a bit moving faster because time is less. Then I will share this slide to you people. The one more things, these are, see, you can draw it quickly. This is for an isolated charge. For isolated positive charge, electric field lines are radially outward. For an isolated, sorry, this should be negative, isolated negative, this is positive, is negative, it is radially inward. And for a pair of equal and opposite charges, इक्वल एंड अपोजिट चार्ज होने से द इलेक्ट्रिक फील्ड दिस वन फॉर ए पेयर ऑफ इक्वल पॉजिटिव चार्जेस एंड दिस इज फॉर डाइपोल एक पॉजिटिव एक निगेटिव होने से डाइपोल वाला पॉजिटिव से निगेटिव पॉजिटिव से निगेटिव पॉजिटिव से निगेटिव और ये अगर ये पॉजिटिव से जाके घूम के इधर आएगा so these are the electric field lines for a dipole or pair of equivalent of or opposite charges you can say for similar charge hone se this is positive charge hone se these are the electric field lines and this is not required for us. Next, the last important topic of this chapter is the electric flux. So electric flux is the for through a given area the number of electric field lines that cross perpendicularly or you can say normally. The generally I hope that most of the physics people they are teaching the students that the number of electric field lines crossing a given area normally is called electric flux. So this diagram shows it all. Suppose this is the direction of the area vector. Okay, before that area vector is the direct actually area is a scalar quantity but in this chapter in this topic especially we take area to be a vector quantity. तो vector होने से उसका एक direction भी चाहिए. We always take the direction to be perpendicular to the surface. So since this is the plane of the surface on this if I draw a perpendicular line that will show the direction of that area. So that's why it is marked as a के ऊपर एक वेक्टर साइन दिया हुआ है तो इट इज कॉल्ड एरिया वेक्टर. तो देखो एरिया वेक्टर का डायरेक्शन और इलेक्ट्रिक फील्ड का डायरेक्शन सेम है तो इस इट मींस हियर द मैक्सिमम नंबर ऑफ इलेक्ट्रिक फील्ड लाइंस विल क्रॉस. सो दैट्स व्हाई द हियर इट इज रिटन इफ द एंगल बिटवीन इलेक्ट्रिक फील्ड एंड एरिया वेक्टर इज 0 degree so it is flux is E into A simply electric product of electric field and the area that will give us the total flux and flux is denoted by phi. I think most of you all know that if the area vector makes some angle with the electric field say theta angle and then in that case see if we resolve it into two rectangular components when electric field is resolved into two rectangular components see along this theta components we always have to take cos component. I think you all know that अगर एंगल आ गया तो क्योंकि मुझे इलेक्ट्रिक फील्ड लाइंस पासिंग नॉर्मली थ्रू दैट एरिया ना तो नॉर्मली निकालना है तो उस नॉर्मल के डायरेक्शन में इलेक्ट्रिक फील्ड का जो कंपोनेंट है वो E cos थीटा आ जाता है ना तो इसीलिए E cos theta into A. So it can be written like this also E dot A cos theta. तो एक साथ लिखने से E cos theta तो हम I can write it as E dot A. तो for any angle theta other than 0 degree or 180 degree I can write flux as E dot A. Dot product of electric field intensity and area vector. I think it is clear ना थीटा कंपोनेंट होने से उस थीटा कंपोनेंट में इलेक्ट्रिक फील्ड को रिजॉल्व कर देना है उस कंपोनेंट में कॉस कंपोनेंट आ जाता है इसीलिए कॉस थीटा एक आ जाता है. तो प्रोडक्ट ऑफ ई डॉट ए और डॉट प्रोडक्ट ऑफ और नहीं तो ई ए कॉस थीटा गिव्स अस द इलेक्ट्रिक फ्लक्स. अगर बहुत सारा है और एंगल्स डिफरेंट है तो वी कैन हैव ए इंटीग्रेशन ई ए कॉस थीटा और ई डॉट ए लेने से उसका सरफेस पूरा सरफेस में इंटीग्रल कर देने से उसको कहते हैं सरफेस इंटीग्रल. तो इट इज कॉल्ड इन दैट केस इफ डिफरेंट एंगल्स आर देयर बिटवीन इलेक्ट्रिक फील्ड इंटेंसिटी एंड द एरिया वेक्टर देन वी कैन यूज द सम. व्हेन वी वांट टू टेक द टोटल वी नीड ए इंटीग्रेशन सिंबल. सो दिस इज अबाउट द नोट्स. तो यहाँ पे देखो एक क्वेश्चन दिया हुआ है फाइंड द इलेक्ट्रिक फ्लक्स थ्रू ईच सरफेस एंड हेंस फाइंड द टोटल इलेक्ट्रिक फ्लक्स थ्रू द क्यूब. तो टोटल तो यहाँ पे दिया हुआ इलेक्ट्रिक फील्ड along z axis is 0 and electric field along x axis and y axis is 10 20x and 10y. तो x and y दिया हुआ है यहाँ पे. The solution is this one on the right surface. See for the surface on the right hand side, this one, see, it is EA cos A वाला तो इलेक्ट्रिक फ्लक्स फील्ड और एरिया वेक्टर ये दोनों पैरेलल है, तो 0 डिग्री cos 0 डिग्री है ना, दैट EY, ये तो EY है, ये 90 डिग्री है, EY तो आएगा ही नहीं क्योंकि इट इज वी आर कैलकुलेटिंग ऑन द राइट सरफेस विच इज ऑन द एक्स एक्सिस, तो ये दोनों ऑटोमेटिक 0 हो जाता है. सो E इंटू ए, E तो 20x इंटू एरिया है 1, आई थिंक इट इज क्वेश्चन में दिया हुआ है, एरिया है मींस साइड इज, ऑल द साइड्स आर ऑफ 1 मीटर लेंथ, सो 1 मीटर 1 स्क्वायर, एरिया मतलब साइड स्क्वायर, तो 20 इंटू एंड दिस डिस्टेंस 1 प्लस 1 2, तो 2 स्क्वायर, 2 स्क्वायर, तो सॉरी 1 स्क्वायर प्लस 1 स्क्वायर, तो 20 प्लस 20 इट कम्स 40. Similarly on the left hand side, left surface this, अच्छा ठीक है मैं दे दूंगा क्योंकि टाइम इज रनिंग फास्ट. तो नेक्स्ट जो इंपॉर्टेंट है जो मैं पढ़ाना चाह रहा था वो है गॉस लॉ इन इलेक्ट्रोस्टैटिक्स. तो गॉस लॉ इन इलेक्ट्रोस्टैटिक्स सेज दैट द टोटल फ्लक्स, एज आई सेड इन दिस टॉपिक ना, टोटल अगर एक पूरा एक कॉम्प्लेक्स फिगर है विच इज एनक्लोजिंग ए चार्ज, उसके लिए वी यूज गॉस लॉ. तो गॉस लॉ मीन्स द टोटल इलेक्ट्रिक फ्लक्स थ्रू ए क्लोज सरफेस is 1 by epsilon naught times the net charge enclosed by the surface. So in epsilon naught, as I discussed earlier, that it is the absolute permittivity, matlab that closed surface is placed in vacuum. तो इसके लिए द मैथमेटिकली वी राइट इट एज फ्लक्स इज फॉर क्लोज सरफेस आ गया, तो ये जो इंटीग्रेशन में देखो एक सर्कल दिया हुआ है, तो इट इंडिकेट्स दैट क्लोज सरफेस, तो इट इज कॉल्ड सरफेस इंटीग्रल, क्लोज सरफेस इंटीग्रल. तो E डॉट A or dA you can say. So this is giving us the total or net flux for any closed surface, and that flux is always charge divided by epsilon naught. तो इसका एप्लीकेशन पार्ट है जो मुझे हम लोगों को यूज करना है फॉर ए पॉइंट चार्ज, छोड़ देते हैं, फॉर इनफाइनेटली लॉन्ग लाइन चार्ज, ये वाला इंपॉर्टेंट है. इसके लिए हमें ये चाहिए कि इफ देयर इज ए लॉन्ग लाइन चार्ज and that charge has got charge linear charge density lambda, then charge density is given as a charge per unit length, so that charge is lambda into L, it gives us the charge. तो यहाँ से यहाँ तक लेंथ अगर L है, यहाँ से तो उस लेंथ L लेंथ में चार्ज कितना है, lambda into L. This much is okay. Now इसके लिए मुझे इस चार्ज को क्योंकि गॉस थ्योरम यूज करना है, मुझे क्योंकि गॉस थ्योरम यूज करना है, I know you people know it, but still I am showing this. Agar if this is the line charge, we have to enclose it. See, we have to enclose it, and it is possible if we enclose it by a cylindrical volume. If we are using it by a cylindrical volume, so see, we are getting three surfaces. This is top, this is bottom, and this is the curved surface. So here, if I use the area vector, this is the direction of area vector, and here the area vector is towards downward. And suppose this is the point where the electric field is to be find out. So electric field is along this direction. अगर इस direction में है, इसका भी कारण है. Suppose from here the electric field is along this direction, and vertically from downward it is along this direction. If we combine these two using parallelogram law of vector addition, the net electric field is always radially outward. The net electric field for a line charge, it is radially outward. So इसीलिए here the electric field is along this direction. So as I said that electric field is radially outward in for these three surfaces. See, for this one it is 90 degree. The angle between the area vector and electric field, it is 90 degree. Here also it is 90 degree. Here also it is 90 degree. So, but in this case, if I use this as the area vector, here see the area vector and the electric field are parallel. So here theta is 0 degree. So when all these three are combined, so E dot A or dA plus E dot dA plus E dot dA, for all those three, this is for surface 1, say this is 1, this is 2, say this is 3. So this is 2. So they will give us net charge by epsilon naught. This is the flux. Gauss theorem says. So first one, theta is 90 degree. So E dot A, it will give us 0 flux. For third one also, see these two are 90 degrees, so they will give us 0. Only remaining this one. So E dA cos 0 degree. It will give us charge enclosed by epsilon naught. So it is E cos 0 is 1. So E electric field और ये dA को integration करना है. So E dA, it is charge enclosed divided by epsilon naught. So see, it is E. This is a cylindrical volume. So surface area of a cylinder is 2 pi RL. So surface area. So it will give us 2 pi RL. It is charge enclosed. In previous case, I told you that if lambda is the charge density, so charge density is charge enclosed divided by L. So charge enclosed, it is lambda into L. So lambda into L. So it is lambda into L divided by epsilon naught. So L cancel. So electric field intensity becomes lambda by 2 pi R and epsilon naught is there. So my suggestion that you can write this answer like this one. E is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught can be written. तो यहाँ पे देखो 2 पाई है, तो 4 पाई लिखने से ऊपर एक 2 देना पड़ेगा, 2 लैम्डा बाय आर. ये क्यों दिया? क्योंकि I can have, when numerical asks, this 1 by 4 pi epsilon naught can be written as 9 into 10 to the power 9, 2 lambda by r. So this is the first one. Next is electric field due to infinitely plane sheet is also there. There also for a plane sheet, you are seeing the diagram that for a plane sheet, if we are having a plane sheet, so when plane sheet comes, it is the case of surface charge density. So we need to know the surface charge density for that one. So if we want to enclose the charge, the figure should be like this one. We need to जैसे if this is the surface, see, if this is the surface which is carrying the charge, so इसको एनक्लोज करने के लिए मुझे ऐसा एक चीज चाहिए, इसको चार्ज एनक्लोज करने के लिए। आई थिंक यू आर सीइंग द फिगर सेज दैट we to enclose this charge we need a thing, we need a figure like this one. We need a figure like this one to enclose that charge. So let me show it in the board. So if this is the plane sheet carrying the charges, to enclose this charge we need a volume, enclosed volume like this one, which is enclosing the charges. And अगर इस area, if this area is A and if the charge density is sigma, so charge enclosed is nothing but sigma into A, because charge density is charge per unit area, isn't it? So I know what is the charge enclosed by this volume. Now here see, here the area vector is along this direction, and here also area vector is along this direction. So electric field can be along this side or electric field can be along this side also. In both the surfaces figures, they are parallel. So the net flux, it is E dot A for this one, say surface 1, and E dot A for surface 2. Surface 2. This one closer. And what about this one? This curved surface, if I take it as 3, so I can also use like this E dot A. Like the previous case, it is surface 3. Here see the area vector and electric field, they are 90 degrees. So it will give us 0 contribution. So answer is these two. So left hand side net flux is charge enclosed divided by epsilon naught, and it is E A plus E A. From these two, let the total area be A. So okay, E dot dA, dA, dA. So E integration dA plus E integration dA. So answer is charge enclosed is this one, sigma into A by epsilon naught, and it is E, it is answer A plus E, answer is E. So sigma A by epsilon naught, it comes as 2E.
64.
So AA got it. So that means 2E, it is equal to sigma by epsilon naught. So E is equal to sigma by 2 epsilon. This is the electric field intensity for a plane charge, plane sheet. Next is the electric field intensity due to a spherical shell or a hollow sphere, you can say. So for that one, we need to know 3 cases. One is outside the shell. Suppose this is the shell. Say here the charges are carried by this shell, and it has got radius r. So suppose outside the point, we need to know the electric field, and on the shell we need to know the electric field. It is on the surface, and in an inside point where this there can be 3 cases. So for that one, for first case, see, if we need to enclose this charge, see, we need a
ट्रांसफर तो ले रहा हूँ टेंशन से
spherical volume. See, because it is a sphere, na.
क्या हो गया?
And for that one, the total charge enclosed is q by epsilon naught. What is the Gauss theorem
कब हो
says?
गया?
It is charge by epsilon naught.
अरे तो हुए नहीं
So
ये
E
बातें।
dA, so it is q by epsilon naught. तो
तो एज के कारण या कुछ और दिक्कत है?
यहाँ पे अगर एरिया वेक्टर कंसीडर करेंगे तो देखो इलेक्ट्रिक फील्ड तो रेडियली आउटवर्ड है, तो और एरिया वेक्टर का डायरेक्शन और एरिया वेक्टर का डायरेक्शन सेम है, तो दे गिव्स अस द एंगल बिटवीन देम इज 0 डिग्री, तो ई डी ए कॉस 0 डिग्री, तो ई डी ए क्यू बाई एप्सिलॉन नॉट, तो डी ए का बिकॉज इट इज ए स्फीयर द एरिया of the sphere is 4 pi r square, तो it gives E is equal to 1 by 4 a, इसको लेफ्ट राइट हैंड साइड लेके आओ, तो 1 by 4 pi epsilon naught q by r square.
नेक्स्ट क्लास का
दिस इज फर्स्ट आंसर. फॉर सेकेंड आंसर, अगर फर्स्ट आंसर मिल गया तो सेकेंड आंसर इजीली आ जाएगा कि इलेक्ट्रिक फील्ड E is equal to 1 by 4 pi epsilon naught q by a स्मॉल r के जगह कैपिटल R, क्योंकि द रेडियस ऑफ दिस स्फीयर, अभी वो चार्ज तो अभी सॉरी फील्ड निकालना है सरफेस में, तो सरफेस में आ गया मतलब डिस्टेंस बिकम्स r कैपिटल R, तो इसीलिए तो स्मॉल r के जगह कैपिटल R बैठाना है. ठीक है. और इनसाइड द पॉइंट, अभी इनसाइड द पॉइंट तो इलेक्ट्रिक फील्ड है ही नहीं, इलेक्ट्रिक फील्ड तो बाहर है, चार्ज बाहर है, तो चार्ज बाहर है, तो इनसाइड द कंडक्टर, सिंस इट इज अ हॉलो कंडक्टर, इनसाइड द hollow conductor the electric field is always 0, तो बिकॉज देयर इज नो चार्ज, मुझे यहाँ पे यूज करना है, यहाँ पे तो कोई चार्ज है ही नहीं, तो
ये भी तो इसी पे
यहाँ पे क्योंकि कोई चार्ज नहीं है तो चार्ज एनक्लोज्ड इज 0, तो ई डी ए शुड बी राइट हैंड साइड शुड बी चार्ज एनक्लोज्ड 0, तो इट इज 0. तो यहाँ पे ब्रैकेट में दिया हुआ है सिंस द टोटल चार्ज गिवन टू द शेल reside on its surface, the charge enclosed by the Gaussian surface is 0, so E is 0. तो तीन देखो, इनसाइड द शेल द इलेक्ट्रिक फील्ड इज 0, तो वो कहां तक 0 हो सकता है? अप टू द रेडियस, अप टू द रेडियस तक 0 होना है. सो तो अप टू द रेडियस इलेक्ट्रिक फील्ड अगर 0 है तो यहां तक 0 है, उसके बाद द दिस पॉइंट कम्स on the surface, on the surface तो इलेक्ट्रिक फील्ड है, all are constant, see all are constant, so this value is suppose this one. अभी इसके बाद आउटसाइड द शेल आ जाता है, आउटसाइड द शेल, तो आउटसाइड द शेल इट depends on this distance, see it is in electric field is inversely proportional to the square of the distance, so the graph say is like this one, inversely proportional. तो see आप from 0 to radius इलेक्ट्रिक फील्ड 0 है, दिस वन, और उसके बाद एट द रेडियस जब सरफेस में है इलेक्ट्रिक फील्ड मैक्सिमम बिकॉज इट इज अ कांस्टेंट टर्म, और उसके बाद इट वेरीज इनवर्सली एज द स्क्वायर ऑफ द डिस्टेंस, सो इट इज इनवर्सली प्रोपोर्शनल लाइक दिस. दिस ग्राफ इज इंपॉर्टेंट फॉर एग्जाम पॉइंट ऑफ व्यू. तो दिस इज द चार्ट विच इज देयर, तो इलेक्ट्रिक चार्ज एंड फील्ड फ्रॉम फर्स्ट चैप्टर. These are the things which I have covered today.
विज्ञान ज्योति का फंडा देगा टीचिंग नॉन टीचिंग क्या
Sir,
116710 ये है, और
this is this one and this one plus. Okay, so advanced and regular subscription total will come this.
रेगुलर कितना है? ये ना
Regular subscription.
716
dear students, I am giving you the feedback form
716 क्या है?
in the chat box.
This one and this one
ये
plus.
0 है ना?
Yes, sir.
Please fill it up and let me know what kind of correction is needed. Sir, it is already 9:30. Shall I proceed or Sir, are you there?
1045. कौन सा है मैनेजमेंट से
Management share, on share,
182238 238 ये वाला ना
yes sir.
38 130
Dear students, one feedback form is given to you. Please you fill it up and let me know what corrections are needed. And today, as after a long time, I am taking the class. So I was asked to take first and second chapter, but I could finish only first chapter. So tomorrow I will be a bit faster one. Sir, are you there?
PPT इंग्लिश को यहाँ अप्लाई कर रहा है
किसका शर्मा का
एक-
फ्रेंड
नहीं मुझे एक कॉल मिला I don't know
शर्मा
कहाँ
बुला
से
रहा था
मिला
एक को अपना टीम बनाएगा
मणिपुर का है सर औरत है
कौन है
मणिपुर का शी इज अटैच
आप जा रहे हो मणिपुर का बुला रहे हो
सीसीपुर का थाना तो वहाँ नहीं रह पाया तो चांदेल में अटैचमेंट है तो इसका स्ट्रॉन्गली लेटर भी आया था ना अटैचमेंट के लिए मणिपुर स्टाफ को तो यहाँ खाली दिखा
हाँ सर ओके सर हाँ ठीक है कल ले लेना बाकी आप क्या करना है ऐसे 1 मिनट में बंद कर देता हूँ स्टॉप रिकॉर्ड हाँ